Okay, quick slideshow on the other two centers involving medians and altitudes in a triangle. So let's start with the centroid. What's wrong with that definition?
Is it not in
No, it doesn't have to be an if-then form. Have it?
We don't know what a median is yet.
Mm-hmm.
So I'm just allowed.
There are words in that definition which you don't know. In particular, a median. But if you look at the picture and realize that BL is a median, then someone should be able to figure out what a median is. What's a median? Ashley, what do you think? First of all, what kind of thing is it?
Line segment.
It's a line segment. Good, I like that. A median is a line segment that
Bisects
what's special? Let's just focus on the median BL. Badger Llama. You with me?
yeah.
What's special about the point L?
It's the midpoint of AC.
Good, so tell me what you know about BL then,
It's the bisector of AC.
right? It's not horrible. There's one small catch that you're
It
missing.
goes through the centromere.
No, we can't use the
Centroid.
we can't use the centroid to define the term which is defined by the centroid being there. So we need to define medians in order to define a centroid. It does pass through the centroid though, that's true. What else does it pass through? Somebody just jumped off the roof.
Snowed, yeah. It's more than
Ooh, look at that mess. Okay, so you said it bisects segment AC, right? But what makes BL special? Because that segment, bigger dot, okay. That segment also bisects AC. So why is BL special?
Because it also passes through angle ABC.
Not so much the angle. That's correct, but what else does it pass through? So instead of eliminate the whole angle, let's just talk about the point B.
Oh, the vertex of the
Yeah,
triangle.
right. So say it again. A median is a line segment that,
Passes through a midpoint and a vertex of the triangle.
perfect.
Say it again.
Say it louder, please.
A median is the line segment that passes through a midpoint and a vertex of the triangle.
Good. So if you look at the median AK, it passes through the point A, which is one of the vertices, and it passes through the opposite midpoint. And then just like what has happened in the other centers, all three of those centroids meet in one point, which we label P here, which is called the centroid. And you know it's going to have some special properties, right?
Dang it.
Of course.
Any guesses? While you're thinking of that, also think about when is it inside, outside, or on the circle. Acute obtuse, so right triangles, for instance. Here's the centroid theorem. Special property of the centroid is that the location of the centroid splits the median into two parts. The part from the vertex to the centroid is twice as long as the distance from the center to the midpoint. So if we look at BL in particular, BP is twice as long as PL. AP is twice as long as PK. CP is twice as long as PJ. Megan? You ready? Yes, you are. If this is 20 from B to P, how far is it from P to L? Nope. It's not the midpoint. Bingo. Good. That's number one. Ready for number two? Too bad. If PK is 5, how long is AP? Good? You ready for the hard one? If CJ is, let's go with something easy. Let's go with 60. How long are CP and PJ? Want some help? If PJ is X, how long is PC? Forget about the 60 for a second. If PJ is X, how long is PC?
Twice the size of X.
Right.
2X.
Also known as 2X. Good. Okay, now, if the whole thing is 60, how long are each of the parts?
40.
And?
45 and 50.
No.
Right, 40.
40 and?
20.
Good. This would be 40. This would be 20. Okay, so those are the two possibilities. Given the shorter distance, the distance from the centroid to the midpoint, find the distance from the centroid to the vertice. That's one. The other one would be given the distance from the vertex to the centroid, find the distance from the centroid to the midpoint. And then the third possibility is given the entire length of the median, find the other two parts. And so you have that x to 2x ratio among that whole side. This is x is 10, that's got to be 2x, 20. This is 2x is 10, so x is 5. And then the whole thing is 60, you get x plus 2x equals 3x. Divide it into 3 parts, put 2 on one side, 1 on the other. Any problems? Beautiful. All right, what about inside, outside, on? Well, that was an acute triangle, and it was inside. What about if it's an obtuse triangle? Inside?
Outside.
Outside?
I don't know.
Inside? Anybody else want to jump on Mary's outside bandwagon?
Mary.
You might be right, Mary. Stick to your guns. Where would it be outside? In the obtuse angle or behind the obtuse angle? Got a 50-50 chance.
I don't know. Outside. The angle?
Outside the angle, okay? Good. And what if it's right?
In the height.
Ben, on? Where on? Hypotenuse. Anywhere on the hypotenuse or the midpoint of the hypotenuse? Okay, let's see what happens. I know it's on my computer, blah, blah, blah. Okay, there's the triangle. There's the centroid. That's an acute triangle. Grab this. There's obtuse, still inside. And there is something looking like a right triangle, still inside. It's always inside. And I believe I gave you some bad information. Whoa, whoa. I believe I gave you some bad information on Thursday. Did I tell you the in-center was the balancing point?
Yeah.
I was wrong. It's a centroid is the balancing point. Sorry. It's not like you're going to be cutting out triangles and balancing them. Who did that sigh come out of?
Not me.
Okay, Mr. Melodramatic. Alright. And the last one. Orthocenter.
Good.
This is the hardest one.
Are all the
Great.
terms like dentist like orthos?
Haven't you learned about prefixes and suffixes in English yet?
Ortho means straight.
Yeah.
A straight center.
Yeah, like an orthodontist is a dentist that makes them straight.
Sure.
Orthocenter is the center that's straight. That really makes no sense here, but you get the idea. Okay, there's the definition of an orthocenter. What in that definition does not make you happy, Madeline?
Altitudes.
Altitudes. Could you tell me what an altitude is? Based on that picture over there. All those red segments are altitudes. And by the way, I'm going to give you a hint there. Because I didn't draw it appropriately, altitudes are actually lines, not line segments, but I just chopped off the line part for the picture. So they are a line that.
They are a line that.
Great start.
Hilarious.
They are lines.
Let me guess, you're going with that next.
Okay.
They are.
They are lines.
Niagara. Too bad, tell me.
Okay, I need to think.
Don't hurt yourself. Focus on this one and this one alone. It'll make your life a lot easier.
I'm telling you what an altitude is.
That is correct.
It's a line that is the side of the right angle.
That is true. It is the side of a right angle. Mr. Shaffis?
It's the line that's the perpendicular bisector of the vertice.
No, because that's a circumcenter.
Ew.
Cole,
Is it the measure?
are you asking me or telling me?
I'm be telling you. I
Okay.
guess. It's the perpendicular distance between a vertex and a base.
Close enough. It's not a distance, but it's perpendicular. Okay. So it's a perpendicular line from a vertex. Wait, let's start over. An altitude is a line. Do that first. That. Thank you, Madeline. Goes from a vertex perpendicular to the opposite side.
Perpendicular to the what?
Opposite side. So, Mr. Shaffis, how does your definition differ from the actual definition? What does perpendicular bisector is perpendicular to a side but passes through,
Oh yeah, this one.
but on the side it passes through? Don't listen to him. He has no idea what he's talking
I have
about.
no idea what. I don't know. The pass to the centroid.
Nope, you're overthinking it. What's a perpendicular bisector pass through? No. Grace?
Midpoint.
Beautiful, passes through the midpoint. They are identical except an altitude passes through the vertex, it's over here. A perpendicular bisector passes through the midpoint. So what can you tell me, what's the relationship between an altitude and a perpendicular bisector? Yes?
They're parallel.
Awesome, they're parallel.
Oh, yeah.
Because they're both perpendicular to the same side.
Oh, I get that.
So where all three of those things meet is called the orthocenter, right there.
Are we having a quiz on these things also?
Oh yeah.
Dang it. Wait, this is all tomorrow?
Acute, right, or obtuse?
I'm done with
Everything outside.
Everything outside.
I agree with
Did
that.
you not just see the triangle?
Everything outside? Darn your voodoo magic. You want to stay with that answer? What about, let's break it down. How about acute?
Inside.
Inside, very good.
Is that true?
Go back, go
I
back.
want to write down correct information.
We all saw the triangle up there. It was there. I'm not imagining things. There is a, if I go back, there is a triangle on that side.
Wait, there's a triangle there?
Okay, so you see it too? Good.
I don't see a triangle.
Okay, so. Okay, right triangle, where's the orthocenter gonna be?
On the hypotenuse.
On the hypotenuse, inside, outside.
Yes.
What do you want?
Inside.
Nothing? You're just waving your hand in the air?
Like, he just don't care.
So what was that again? GSP.
Okay, there's the orthocenter, there's the acute triangle that you all see, right?
Yeah.
Okay, good. So it stays inside. Now if I make it obtuse,
Oh no.
oh, no!
Right.
Outside on the obtuse.
Outside but behind the obtuse
I
angle.
should have said that for this.
Remember, the circumcenter is outside but inside the obtuse angle. This is outside but behind the right angle. And then if you caught it when it came by, where is it on a right triangle?
On the hypotenuse.
Right
No,
vertex.
it's
On
the vertex of the right angle.
Okay.
What do you mean by behind? That's what you're saying.
Here's the obtuse angle.
Yeah.
Here's the obtuse angle. If it's inside here. If it's behind, it's back behind the vertex.
Oh,
Okay.
there's another side.
Now, I am going to, let me stop the recording here.